Okay. Okay, so I'm sharing my screen with you, and these are those electrolysis past papers that are given by the school to everybody. I hope everybody received these. And so I am going backwards from 2015 backwards, because I've heard that the teachers have recommended to solve past papers after 2005. I mean, from 2005 onwards, right? So let's go backwards from latest to older papers, right? So, okay, let's start with this question. The diagram shows the electrolysis of molten lithium bromide. If you have this printout, if you have these questions print out in front of you, it's great. But for those who don't have, they can refer to my screen. The diagram shows the electrolysis of molten lithium bromide, right? And then the diagram is simple. They have a power supply with the positive and the negative terminal and the electrodes within the molten lithium bromide with the heat at the bottom, because of course it's molten. Now mark on the diagram the direction of the electron flow. Mark on the diagram the direction of the electron flow. So let's see. Okay. From cathode to anode, from right to left, from anode to cathode. No, this is not how you will answer. No, no, no. How will you will tell me in terms of the terminals of the battery. You will tell me in terms of the terminals of the battery. Because see, now let me also clear this one point that you know, the electrolysis is a reaction that is this electrolysis reaction is taking place in response to the flow of electricity. It is taking place in response to the flow of electricity. This reaction is not producing electricity. Are you getting me? The electricity is causing this reaction. This reaction is not producing electricity. So by the way, we have not done those reactions that produce electricity. We have not done those reactions. We have only done in IGCSE, I mean, so far, what you guys have done, it's only the reactions which are caused by electricity. We have not done those reactions which are causing electricity or which are producing electricity, okay? So you will give me the direction of the electricity with respect to the terminals of the battery. Yes, Hala, yes, from the negative terminal of the battery to the positive terminal. Right, so it's easier for you and there is no confusion, right? It's easier. Okay, let's go on. Part 2, write an ionic equation for the reaction at the negative electrode. At the negative electrode. Ionic equation at the negative electrode. Now, first of all, tell me what two ions are present in this setup. What are the two ions that we have? One must be a cation and the other must be an anion, right? Because it's molten lithium bromide. Good job, Hiba. I like it. Lithium ions accepting one electron to be deposited as lithium. So this is reduction, right? Because reduction is the gain of electrons, which will take place at the cathode, which is negatively charged electrode, because cathode is the site of reduction, right? So the ionic equation at the cathode would be this, right? What you just wrote, Hiba. Okay, that's the ionic equation. Now, write an ionic equation for the reaction at the positive electrode, anode. Anode. Good job. 2 bromide, but you forgot the negative charge. But yeah, I know you don't have that option maybe. So yeah, 2 bromide giving bromine and releasing 2 electrons. I hope everybody, do you guys want me to explain you how to write these equations? Okay. Do you guys want me to explain you how to write these equations, or you know it? You're good. Okay, if anybody wants me to explain how to write these equations, then please let me know through the chat window. Okay, which ion is oxidized? And explain your answer. Which ion is oxidized? And explain your answer. So oxidation is the loss of electrons. Yes, yes, because yes, bromide ion, because it lost an electron, and so loss of electron is oxidation, right? So it's oxidation state raised from -1 to 0. Okay, good job. Next, um, when aqueous lithium bromide is electrolyzed, a colorless gas is formed at the negative electrode and the solution becomes alkaline. Explain these observations and include an equation in your explanation. So what is this colorless gas, first of all? What is this, Ajwa? Bromine gas is colorless? Is bromine gas colorless? Yes. Okay. Hydrogen, Hala. Okay. Explain why. Okay. Yes. Good job. Hydrogen. But why? Explain it. Any explanations? Why did you say hydrogen? What made you say hydrogen? Okay. Let me, okay. See, now if this is aqueous, yes, yes, good job, Sadaslam. Yes, because hydrogen is less reactive than a lithium. This is my reactivity series in case you don't have it. So we can see that hydrogen is here and lithium is here. So lithium is one of the top 3 most reactive metals. So lithium is no way gonna be reduced, okay, because it won't go from a stable to an unstable form, right? So it's pretty stable in the form of a cation, and so it won't get reduced, and instead hydrogen will be reduced, and therefore hydrogen gas will be released at which of the electrodes? Now hydrogen is a cation, so it would be attracted towards the cathode, which is the negative electrode, and it will accept electrons and 2 hydrogen atoms in the form of hydrogen gas. Right, so what equation do they want in the questions? Write an equation in your answer. The equation would be this hydrogen ions accepting electrons to form hydrogen atoms, but hydrogen does not exist as an atom. It exists as a diatomic molecule. So 2 hydrogen atoms and each 2 hydrogen ions, and each ion will accept 1 electron. So for 2 hydrogen ions, 2 electrons, giving us 1 molecule of hydrogen gas. This is the equation, right? And what is left behind? That's the other question, right? What is left behind? So at the anode, what are the 2 anions we have? What are the 2 anions we have in this particular example? Bromide and hydroxide, right? And the cations were lithium and hydrogen. So bromide will be preferentially released. So bromine will be released, right? So hydrogen is getting released, bromine is getting released. What you are left behind with is lithium hydroxide, which is an alkali, right? So alkaline solution. Lithium hydroxide is what is left behind, which is a pretty alkaline solution. So you will explain all of this, that at the anode, the bromide ions are still getting oxidized to release the brown gas bromine, leaving behind the alkaline aqueous lithium hydroxide. I have already, Sayyid Nabil, I have already mentioned in the group, not once, so many times, even yesterday, we are doing past papers. Okay, you know, in the middle of the lecture, if you ask questions like that, it breaks my, you know, tempo. Okay, so let's move on. That's fine. Okay, let's move on. Then this question. The ions present in aqueous sodium chloride are No, this is a different question. This one, part C. Now, by the way, this was a big, long question, and they just took out a part of it because only this part dealt with the electrolysis part. The rest of it was about the extraction of zinc from its ore, right? So it involved reduction by carbon and all of that stuff. So only this was related to electrolysis. So they gave this only. The zinc produced by this process is impure. Which process are they talking about? Reduction by carbon, extraction from its ore. It can be purified by electrolysis using a method which is similar to the purification of copper. Under the conditions used in the process, the zinc is the product at the negative electrode cathode. Complete the following description of this purification. Now, another thing that I noticed while I was going through these questions is that whenever in the question they mention that this process is similar to this one, then when they tell you in the question that this process is similar to that other one, then just assume that you are being asked about that same process. Like, for example, when they mentioned here that it can be purified by electrolysis using a method which is similar to the purification of copper. So just keep the purification of copper in your mind. You might not have done the purification of zinc, but just keep purification of copper in your mind, and it will be exactly the same way. Because they want you to think that way. That's why they have mentioned it in the question, because they want you to think in that way. Under the conditions used in the process, zinc is the product at the negative electrode cathode. Complete the following description of this purification. The electrolyte is aqueous. So do you remember the purification of copper? Do you guys remember the purification of copper? What should be the electrolyte? Electrolyte is aqueous. Good job. Zinc sulfate. Why? Why did you choose zinc sulfate? Why did you choose zinc sulfate? Can we have zinc nitrate? Can we have zinc nitrate? Yeah. Can we have zinc chloride? Yes, we can. So what sure? Yes, soluble salt of the metal, right? Any soluble salt of the metal, right? Which will not affect our results. And our purpose here in this particular question is to purify zinc, right? So whether it is nitrate or sulfate, don't use chloride, because chlorine may be discharged at the, don't use any anion which is less reactive than hydroxide. Oh, yeah, which is less reactive than hydroxide. Look at this. Am I showing you my video? Okay, look at this. See, these ions will preferentially stay in solution, okay? Carbonates, nitrates, sulfates, okay? But if you have these halides, and if the concentration is greater of these, then they are released at the anodes, okay? So be careful, okay? Choose, to be on the safe side, choose an anion which won't be discharged and which would be left behind, okay? So because we don't want anything unnecessary being released at the electrodes, right? So sulfate and nitrates are our best bets, okay? Carbonate mostly are insoluble, except for the group 1 and group 2. So sulfates and nitrates are the best bets, okay? Okay. Okay, so, okay, the negative electrode is made up of, the cathode is made up of, cathode should be made up of, in the purification of copper, we discussed that cathode should be made up of pure zinc. Yes. Yes, impure zinc. Good job, Huria. Why? Saad Amir, not carbon. You don't remember purification of copper? Yes, impure zinc. Yes. Why? Why? Also tell me why. In real short. Nabil, you have to mention what zinc, pure or impure. The next sentence says that the anode is impure zinc. Yes, so that is why. So that's why you said that the cathode should be pure zinc. Is that the reason? Because the question said that, or because you remember something from purification of copper? Why did you? See, what will happen at the anode and what will happen at the cathode? Think about it. See, what is happening at the anode and what is happening at the cathode? Let's see. At cathode, you have reduction going on, right? At cathode, you have reduction, and reduction is the addition of electrons and therefore deposition of the metal, right? So you will have the metal getting deposited at the cathode. So your cathode should be what you want to uh, where you want the copper, where you want the zinc deposited, where you want the zinc deposited. So pure zinc. So, you know, you already have a thin sheet of pure zinc, and then you will have more zinc layers getting added onto it, right? That's the purpose. At the anode, what's happening at the anode? At the anode, you have loss of electrons. So basically you have oxidation going on in here. So impure zinc will lose electron and will be entering into the electrolyte, will be getting added to the electrolyte in the form of zinc ions. And then the same zinc ions, or, you know, from this aqueous, or, you know, this electrolyte will be then providing those zinc ions for getting reduced. Remember, reduction is the deposition of metal. Reduction is the deposition of metal. So zinc ions from the electrolyte will be attracted, because they're positively charged, they will be attracted towards the cathode, and they will accept the extra electrons. They will accept the electrons, okay, and then they will be reduced. They will be reduced into zinc solid form. Okay, so we will start with pure, thin sheet of pure zinc, where we will get further layers of zinc deposited, right? So impure zinc should be the anode and pure zinc should be the cathode. Did you guys understand? The same was happening in purification of copper, if you remember. This is negatively charged, this is positively charged. Did you guys understand? Did you understand? Metal will come at cathode. Then, yeah. See, pure metal, but beta, which metal? Both the electrodes are metal in this case. Both the electrodes are zinc, but the anode is impure, because that's where the zinc ions will get released. They will get oxidized. They will get released into the solution. And it is at the cathode where the deposition will take place due to reduction. Okay, I hope you understood. If there's anybody who wants me to explain this again, please let me know. Did you guys understand? I explained this to you when we did purification of copper, but I can explain again if anybody wants me to. Should I move on? Again? Okay. Okay. Give me a... Okay, so hold this for me. Now, see, we are trying to purify zinc, okay? And I don't know if you were in that class or if you have heard that recording in which I explained purification of copper. These are two electrodes, right? And we are trying to purify zinc, okay? This is the anode and this is cathode, okay? Now, should I, like, do I have to explain you from the beginning? Like, why do we have a soluble salt of zinc as the electrolyte? Or do you know that? We should have a soluble salt of the metal that you're trying to purify. So if you're trying to purify zinc, so I should have, beta, I have the recording. You guys can go back and listen to it, because then I'll be just doing this the whole class, during the whole class. We won't be able to do more questions. But okay, I'm gonna explain you as much as I can, okay? And then let's see. Okay, so aqueous solution, meaning we have hydrogen ions, hydroxide ions, and then we have zinc and sulfate. Now, why did we use zinc sulfate? Is because we want a soluble salt of the metal that we are trying to purify, right? Cathode is the site for reduction. I hope you guys know this. And anode is the site for oxidation. Okay, I hope you know oxidation is the loss of electrons, right? And so when zinc, now this is zinc, right? So zinc at the anode will undergo oxidation, which is loss of electrons, right? Right. Cathode will be having this process going on, okay? Gain of electrons and getting deposited. So basically, we are trying to get, this is a thin sheet of pure zinc. We are trying to deposit layers of zinc onto it, okay? The layers of zinc will be deposited on this thin sheet of pure zinc. The impure anode will have the zinc ions getting released. Zinc ions will be released undergoing the process of oxidation by losing electrons. They will be converted into cations from the neutral atoms to cations. They will lose electrons, getting oxidized into zinc ions, getting added into the electrolyte, right? And then this salt already had zinc ions, and because of the opposite charges between the cathode and the cation will be then attracted towards the cathode, where there is an excess of electrons. Why? Because it is connected to the negative terminal of the battery. And there it will accept these electrons and get deposited as pure zinc solid. And so by the passage of time, after passage of time, you will see layers of pure zinc getting deposited onto the cathode, right? Right. So the concentration of the electrolyte or salt will stay constant. Why? Because the rate of ion entering into it is the same as the rate of ion getting deposited from the solution into the cathode. So therefore, the net loss is zero. I mean, whatever is leaving, whatever is entering is equal to whatever is leaving. Okay, so there is no net change in the concentration of the salt. And that is the reason why we have chosen a soluble salt of the metal. First of all, to complete the circuit, okay, because this is a whole circuit. And secondly, to keep a balance of the negative and the positive charges, okay. And third is to ensure a continuous supply of this cation for the purification, for the deposition, so that we don't run out of these zinc ions, So I hope this is the best I could do, and I explained it really well with, with all those models and with all those colorful cutouts. I worked so hard to explain you guys, but I hope now you remember. Okay, Zen? Okay. Did you understand? Are you convinced now? So pure zinc should be cathode and impure zinc should be the anode. Okay, write it down somewhere. Okay, impure thing should be the anode and pure thing should be the cathode. Thing meaning metal. Okay, okay, let's move on. Yes. Okay. Okay, so now we know the negative electrode is made of uh, pure zinc. The positive electrode anode is impure zinc. The equation for the reaction at the cathode is, I already wrote down. The equation for the reaction at the anode is, I already wrote down. Explain why the concentration of the electrolyte does not change. Why doesn't the concentration of electrolyte? Yes, good job, Hiba. Good job. Yes. Why doesn't the concentration? This is because the zinc ions are continuously removed from the solution and replaced into the solution at the same time. Okay, good job, Hiba, but just little changes and improvements in this question. Write down that the rate at which the zinc ions are being removed is equal to the rate of the ions being added due to oxidation at anode. So when you will equalize the rate, you will be better explaining, right? You will be better explaining why the concentration stays the same, right? Right. So if you will write it that way, it would be better. But yes, your answer is correct. Okay, let's move on to this question. The ions present in aqueous sodium chloride are sodium, aqueous ion, sodium ions aqueous, chloride, hydrogen, and hydroxide. The electrolysis of concentrated, now remember it's concentrated. Concentrated aqueous sodium chloride forms three products. They are hydrogen, chlorine, and sodium hydroxide. Why did I ask you to pay attention to the term concentrated? Because if it is dilute, then the product at the anode will be, no, the product at the anode will change. Yes, halogens are released at the anode only when their concentration is greater. Otherwise, oxygen is released. Okay, be careful. Okay, explain how these three products are formed. Give ionic equations for the reactions at the electrodes. This is, I think you guys have done this, but let me do it again. I need a paper. Okay. Okay. Hiba, you are the only one participating. Where are others? Why aren't others participating? Where are the participants? Come on. Aisha, Nadeem, Huzaima, Usman. What happened to you guys? Why aren't you participating today? Come on, Yusra. Ajwa is participating. Okay. Okay, so now in this, now I am, sorry miss, I'm dumb. Hydrogen formed at cathode and chlorine at anode, and sodium ions and hydroxide ions are left to form sodium hydroxide. Wonderful, Ajwa. Yes, good job. You made my life easier. So do I have to explain this? If anybody wants this to be explained, then let me know. Otherwise, this is such a easy question. No? Okay, no. Zen, what about you? You want me to explain this? Josefa, do you want me to explain this? No need to explain? Okay, good, good, good. Okay, let's move on. Let's save time. Uh-oh. Okay, let's move on. Okay, this is extraction of aluminium. In the modern method, aluminium is obtained by the electrolysis of aluminium oxide alumina, dissolved in molten cryolite, and molten cryolite formula is this, Na3Alf6. Okay, the major ore of aluminium is impure aluminium oxide. What is the name of this ore? Do you know the name of the ore of aluminium? Yes, Hania, good job. Bauxite it is. Yes, good job. Bauxite, yes, okay. This ore is a mixture of aluminium oxide, which is amphoteric, and iron 3 oxide, which is basic. What does amphoteric mean? What does amphoteric mean? Yes, an oxide which, yeah, which can react with both acids and bases. Yes, and alkalis. Right, right. Reacts with both acids and alkalis. Yes. So the ore is a mixture of aluminum oxide, which is amphoteric, and iron 3 oxide, which is basic. Explain how these two oxides can be separated by the addition of aqueous sodium hydroxide. Oh, okay. Now, sodium hydroxide will only react with, sodium hydroxide is an alkali, right? We all know that. So is anybody will dissolve, whereas iron oxide will not. And then we can filter it. Good job, Hiba. It can act as an acid in presence of a base and vice versa. Yes, yes, Hania. Yes, that's right. So yes, so when we will add sodium hydroxide, only aluminum oxide will react with it because aluminum oxide is amphoteric, because it can react with both acids and alkalis, whereas iron 3 oxide is basic itself, it won't react with sodium hydroxide. Okay, and so aluminum oxide, when it reacts with sodium hydroxide, what does it do? What does it make? What does it form? When aluminum oxide reacts with sodium hydroxide, cryolite is what we add into aluminum oxide to decrease its melting point. So it's like sort of an impurity. So it has two functions. It increases conductivity because it increases conductivity because it provides with the ions required for conductivity. And secondly, it also behaves as an impurity and it lowers down the melting point, and therefore less energy, less electricity is required for the whole process, right? Yes, so aluminum oxide will, I don't remember the reaction between aluminum oxide and sodium hydroxide, and then, but it won't react, and so iron oxide will, and so maybe that's why we can separate them, right? Yeah, sodium aluminate. Yes, good job, Arham, good job. Yes, sodium aluminate, and then is that it? Or do we have water forming as well? Yeah, sodium aluminate, and then, okay, give two reasons why the electrolyte contains cryolite. I have given you the two reasons, okay? Conductivity as well as lowering of the melting point. The mixture of gases evolved at the positive electrode includes carbon dioxide, carbon monoxide, fluorine, and oxygen. Now, fluorine, remember, is coming from the cryolite. Remember, the cryolite has the fluorine atom in it. Right? Explain the presence of these gases in the gaseous mixture formed at the positive electrode. Include at least one equation in your explanation. Now, okay, so carbon dioxide is due to the, okay, let's do this properly. Okay, yes, the answer to part 2, I hope you guys got it, that one is reacting with sodium hydroxide, the other one is not, and because of that, we are able to separate them, but I will get into the details of this, okay, and then I will get back to you guys. I will let you know in the next class, okay, but let's do this part 4, okay. Wow, Hiba, you are really prepared. You have the marking scheme in front of you because you're answering so well. Right. Okay, I'm sharing my screen. Let's do this in a sequence, okay? So at the cathode, now they are asking us to explain the presence of these gases and include equations. So let's see. Hydroxide is at the, will be released at the, oxygen will be released at the anode, right? So at the anode, right? Hydroxide will give us oxygen and water, right? So 1, 2, 3, 4. So 2 2s are 4, and then 2 here. No, not 2 here, 4 here, 4. Because now we have 4 oxygen atoms and 4 hydrogen atoms. So we have 4 minus charge here, should have 4 electrons here to electrically balance it, right? So you can write this equation, and then this oxygen will react with the carbon of the anode. This oxygen will react with the carbon of the anode. Remember, the anode and the cathode are carbon, right? Or graphite will form carbon dioxide. Or you can even write this equation, that carbon is reacting with oxygen to form carbon monoxide. And so how will you balance it? 2, 2 here, and then 2 here. So yeah, so you can write these equations, and then no need to write fluorine, no need to write how fluoride, or maybe, you know, fluoride. You can write, you know, if you're, yeah, you can write these equations, any of these equations, okay? The mixture of gases evolved at the positive electrode includes this. Explain the presence of these gases in the gaseous mixture formed at the positive electrode, and include at least one equation in your explanation. You can write all of these equations and explain them, you know. Hydroxide is an anion, gets attracted towards the positively charged anode and undergoes oxidation, which is the loss of electrons. And then that oxygen reacts with the carbon of the electrodes to form either carbon dioxide or monoxide. And at the same time, the cryolite is providing the fluoride ions, which can also be attracted towards the anode and undergo oxidation and lose electrons and form the diatomic fluorine. Okay. A major use of aluminium is the manufacture of pots and pans. One reason for this is its resistance to corrosion. Explain why aluminium, a reactive metal, is resistant to corrosion. Good job, Aisha Nadeem. Yes, it has a protective layer of aluminium oxide. Yes. Suggest 2 other reasons why aluminium is suitable for making pots and pans. Okay, high melting point, good job. Any other? Better, good conductor. Yes, because remember, in pots and pans, we're trying to fry, we're trying to cook. So we want good conductors. And yes, high melting points, we don't want them to melt. And what else? Yes, low density, which makes them easier to handle, and they're less heavy. And yeah, all of these points will be considered correct, right? Unreactive to the food, yes. Yes, good job. Unreactive to the food is a good one. Okay, then let's move on. Aluminium is obtained by the reduction of, this is a different question, right? Aluminium is obtained by the reduction of aluminium ions to aluminium atoms. Write an ionic equation for the reduction of an aluminium ion to an aluminium atom. Easy peasy, right? Okay, should we move on? Yes, good job. Yes, thank you, Hiba. Now, part B. The original method of extracting aluminium involved the reduction of aluminium chloride using the reactive metal sodium. Aluminium obtained by this method was very expensive due to the high cost of extracting sodium from sodium chloride. Complete the equation for this reduction. How will you write this? Okay, let me show you the video. Okay, what was the equation? Yeah, here. So I'm writing it here. Aluminium chloride with sodium giving 2 products, right? So now this is in compound. They are saying that aluminium is obtained by using sodium. So because sodium is more reactive than aluminium, so it will displace it. It will kick it out, single displacement reaction, right? So Na will take, sodium will take place of aluminium, and it will make a compound with chlorine itself, and NaCl plus aluminium will be out. That's how we get aluminium. That's how we get pure aluminium. So how will we balance it now? Because it should be balanced, right? So we have 3 chlorine here, so that We should have 3 here as well, and then 3 here as well. So yes, now it's balanced, right? So this should be your answer. How can sodium metal be obtained from sodium chloride? Yes, now remember, we cannot reduce this sodium chloride because sodium is highly reactive, and we cannot have a more reactive metal than sodium that would make the reaction more vigorous, more dangerous. Yes, and so a chemical means won't be good way. Electrolysis using electricity would be a better way. So yes, using molten sodium chloride, we can have sodium. Why not aqueous? Because in aqueous, hydrogen will be released. No, Hania, they are not asking how to obtain sodium chloride from a solution. They are asking how can sodium metal be obtained from sodium chloride? Like what they are trying to ask is like, you have sodium chloride, how do you get sodium out of this compound? How do you get sodium out of this compound? Right? So this is not a this is not a physical chain, this is a chemical chain. So you will melt it so that these ions are mobile, and then by electricity, this will get attracted towards the cathode, and so you will have the sodium deposition. That's how you will pull the sodium out of sodium chloride, right? Okay, let's move on. Okay, the solution. Okay. The solution of zinc sulfate is electrolyzed using inert electrodes. This electrolysis is similar to that of copper 2 sulfate with inert electrodes. Again, this question came. Whenever they ask you, whenever they mention in the question that this process is similar to that one, then that means that this process is exactly like what you read. So now this electrolysis would be exactly like the electrolysis of copper 2 sulfate. I mean, exactly. Write the equation for the reaction at the negative electrode. Who will tell me? Now, this was what? This is zinc sulfate solution. So this is aqueous. So how many cations and anions do we have here? We have zinc ions. We have zinc ions. We have sulfate ions. We have hydroxide and hydrogen from water. So this is negative, this is positive. Okay, let's see. Why zinc? Why zinc? Shouldn't hydrogen be released? Because less reactive is deposited, right? So hydrogen should be released, not zinc. Less reactive is released, right? So hydrogen should be released. Why zinc? आप लोगों के पास वो है marking scheme है. Beta, you should give me reason. You should give me reason. Tell me the reason. Okay. Now let me tell you. What? Yeah, the thing is, yes, it is zinc that is getting deposited. Because I know you guys saw in the marking scheme, so you know that zinc is deposited. But it is not fitting into what we have learned, right? So did you ask yourself, how come zinc, if you know the marking scheme, did you ask yourself, did you search on why on earth is zinc getting reduced here instead of hydrogen? Zinc is way above hydrogen in the reactivity series, right? Look at this. Am I showing you the video? Yes. Yes. So zinc is here, hydrogen is here. So it should be it should be hydrogen getting released, but no, zinc is getting released. This is an exception. Okay, this is an exception. Science has this notorious habit, this bad habit of breaking its own rules. Okay, so yeah, according to the rules that we have studied, it should be hydrogen. It should have been hydrogen, but no, it's zinc. So yes, that this is an exception. Now, if you ask me, is this exception works with other metals? I don't know. I don't think so. Okay. Yeah. So when I was going through this question, I have no idea. I don't know. I tried to search for the reasons, but they were going into calculations, and at the end of the day, those people also concluded that this is an exception, and they don't know the reason why this happens. But I think it has to do with the concentration as well. If the zinc ions are highly concentrated, it would be zinc. But yes, again, and the difference in reactivity is not less. It's pretty high. Zinc is way up there. No idea. I don't know. Okay. And then, okay, so this is the answer to this. Complete the equation for the reaction at the positive electrode. So can you complete this? No, yeah, the anode reaction is this. Hydroxide giving oxygen. Do you know, this is the same equation that I just wrote. This is the same equation that I just wrote down, this one. Am I showing you my video? Yes. 4 hydroxide giving oxygen and water. Okay, and then you saw how I balanced it. Okay, write this equation again and again and again until it becomes a reflex for you. I'll write it down again for you. Hydroxide giving oxygen, you know that, and then you have hydrogen here, so you should ask what happens to the hydrogen. Hydrogen forms water, and then you see 1, 2, 3 oxygen here and 1 oxygen here, and 2 hydrogen here and 1 hydrogen here. Okay, so if I add 2 here, then I get 4 hydrogen atoms and 4 oxygen atoms. So that gives me an even number, and I can safely write 4 here. But then the equation should also be electrically balanced. If I have 4 negative charges here, I should have 4 negative charges here, which I can write in the form of electrons, because this is oxidation, loss of electrons. Okay, so the electrolyte changes from zinc sulfate to 4 times you write it, you learn it. I tried. Good job, Arham. Good job. Now, why is sulfuric acid left behind? Now, remember, in copper sulfate electrolysis, same thing happens. That's why they mentioned, even if you did not know about this exception, this is why they mentioned in the question, because they wanted you to keep the products of copper to sulfate in mind. So just like in copper sulfate, but in copper sulfate, I mean, we understand copper gets deposited because copper is less reactive than hydrogen. So copper's deposition is understandable, but zinc's deposition is not understandable. But anyway, so if zinc is deposited and on the anode hydroxide is deposited, so oxygen is being deposited, then what we are left behind with is sulfuric acid. See here, zinc is gone because it's deposited, right? Hydroxide is gone because it is deposited. So what we are left behind with is sulfuric acid, right? Okay, let's move on. Okay. Okay. A method being developed to produce iron with lower emissions of carbon dioxide is by electrolysis. Hematite iron 3 oxide is dissolved in molten lithium carbonate and electrolyzed. the ore is split into its constituent elements. Write an equation for the reaction at the negative electrode. Okay. At the negative electrode, the cations will be attracted towards the negative electrode, right? So what are the cations here? Yeah, but the other cation is lithium as well. Other cation is lithium as well. So you have, why is same question repeated? What? Which same question? Beta, these are past papers. You will see repetition. Okay, so where am I showing my video? Yes, okay. So we have, these are the compounds, okay? Iron 3 oxide, which is hematite, and molten lithium carbonate. Lithium carbonate. Right. So cations are iron, lithium, anions are oxide and carbonate. So now lithium is way more reactive than iron, right? Lithium is way more reactive than iron. So it would be iron that will be deposited at the cathode. It would be iron. So yes, you will write the equation for iron getting reduced. Okay, now complete the equation for the reaction at the positive electrode. So oxide. Now carbonate, I told you anions, carbonate, nitrates, and sulfates, they remain. And it is the hydroxide or maybe the oxide which is preferentially discharged. So oxide will be forming oxygen. And so 2 here, but then this is not electrically balanced. -4, so 4. I should have written 4 here. Right. So it is like this. Yes. Okay, and 4 electrons because the equation should be electrically balanced as well. -4, -4. Right? Okay. Let's move on. Yes. It will be iron as it's less reactive than lithium. Right. Yes. Okay. Then let's move on to this other question. During electrolysis, ions move in the electrolyte and electrons move in the external circuit. Reactions occur at the electrodes. The diagram shows the electrolysis of molten lithium iodide. Draw an arrow on the diagram to show the direction of the electron flow in the external circuit. So now tell me, from negative terminal to positive terminal. Good job. Yes. Okay, because electricity is making the reactions occur. Okay. Electrons are supplied to the external circuit. How and where is this done? From where do the electrons come? From where do where are the electrons coming into the circuit? From the, yeah. No, I couldn't hear you. Yes, from the battery. Yes, from the negative terminal of the battery. Right. Yes. Because remember, reactions that produce electricity we have not done. Okay, those are called galvanic cells. I don't know if you have gone across your book, the extra topics that are not included, then you will find galvanic cells. That part deals with reactions that produce electricity. Okay, galvanic cells. Okay. Yeah, by the way, battery is a galvanic cell. Within the battery, there are chemical reactions taking place which are producing this electricity but we just call it battery, that's it. Okay. So let's move on. Okay. Okay. Explain why solid lithium iodide does not conduct electricity, but when molten, it is a good conductor. Yeah, what? Yes, yes. Ions, free ions in molten mobile ions. Yes, okay. Free, by free you mean mobile, yes. But you will talk about, you will say the whole thing. You know, heating will free the ions, heating will make them mobile, otherwise they are fixed in their positions and they will not be able to conduct electricity. Right. Yes, Ajwa, this is a good answer. Solid lithium iodide does not have free and mobile ions to carry the current, whereas liquid sodium. No, don't talk about sodium. Talk about lithium iodide only. Solid lithium iodide. Whereas liquid lithium iodide has free ions. Okay, let's move on. You know this. Okay, then this is another. Aluminium is extracted by the electrolysis of a molten mixture of alumina, which is aluminium oxide and cryolite. And then this is the whole diagram. Alumina is obtained from the main, we know this, bauxite. Explain why it is necessary to use a mixture alumina and cryolite rather than just alumina. We know it because jaldi bata do. Lower the most, lower the MP, you meant to say? Lower the melting point. Yes, yes, to lower the melting point and then add on to it. And why do we lower the melting point? Because we that saves us energy. We have to use less electricity to melt it, and therefore that saves us energy, right? Saves us money, right? Copper can be extracted by the electrolysis of an aqueous solution. Suggest why the electrolysis of an aqueous solution cannot be used to extract aluminum. Melting point is high of aqueous solution of aluminum. See, copper, I'm repeating the question. Copper can be extracted by the electrolysis of an aqueous solution. Suggest why the electrolysis of an aqueous solution cannot be used to extract aluminum. And so hydrogen ion will be discharged at the cathode instead of aluminum ion. Yes, Hiba. Yes, your answer is correct. Aluminum is higher in the reactivity series. It is more reactive than hydrogen. And so hydrogen ions will be discharged at the cathode instead of aluminum ion. Hydrogen ions will be preferably discharged. Aluminum is heavy than hydrogen. No, but it doesn't have to do with heaviness. Okay, it has to do with reactivity. Which ion will accept the electrons and undergo reduction? Okay, so that has to do with reactivity. Okay, and we're not talking about density here. I mean, even if aluminum is heavy, we can have it deposited at the bottom, right? That's what we do in the extraction of aluminum, right? The ions which are involved in the electrolysis are aluminum and oxide. The products of this electrolysis are given on the diagram. Explain how they are formed. Use equations where appropriate. So now they want you to write the anode and the cathode equations. That's easy. Aluminium 3+ accepting 3 electrons, getting deposited as aluminium solid, and oxide undergoing oxidation, giving oxygen molecule, right? You want me to write it? You want me to show you? You want me to show you? Explain how they are formed, and then you will write all of this, okay? The uses of a metal are determined by its properties. Foods which are acidic can be supplied in aluminum containers. Explain why the acid in the food does not react with the aluminum. Protective aluminum oxide layer forms, right, which does not react with any acids in the food. And by the way, the acids present in the food are weak acids. They are not strong acids. Okay. Explain why overhead electrical power cables are made from aluminum with a steel core. They're used in the cable because of oxide layer. No, wait, yeah, you will talk about conductivity first, because you have to explain and justify their use in power cables. Yeah, but still, you know, talk about conductivity, that, you know, despite being lower in density, it has appreciable, very good conductivity as well. And so to prevent sagging, because, you know, if we use copper is really dense, and so it would cause sagging of the power cables, and so pylons have to be arranged closer together, and that would be, you know, more expensive and also hideous, right? So we'll have, you know, we'll have pylons everywhere. So in order to reduce the number of pylons so that we can have longer power cables and fewer pylons, we want cables to be conducting as well as sagging less. We want less sagging, and for that we use the less dense aluminum. Okay. Okay, let's move on. Oh, it's 9 o'clock. Okay, it's 9 o'clock. So inshallah, tomorrow I was thinking that we do physics. Which chapter? We do physics past papers of expansions of liquids, expansions of solids and liquids. Yes, expansion of solids and liquid. Your clock is broken. It's 8. Jazakallah khair. Yes, Jazakallah khair for to you guys as well for bearing with me. And so suggest, you know, I was thinking, Arham, I think you missed the expansion of solids and liquids chapter, right? Your mother told me that you missed physics expansion of solids and liquids. So I was thinking that let's do those past paper questions. Do you guys, has the school provided any past paper questions related to expansion of solids and liquids, or pressure, or specific heat capacity? If you guys have any physics past papers that you want me to do with you tomorrow, then let me know. Otherwise, we can continue with same chemistry. We can do the rest of the electrolysis questions. Or we can even do biology. I will read it. No, yes, no, yes, they have a booklet. Yes, I have. Compiled. Chemistry, please. Can we do the ones Miss Amal gave us? Yes, yes, sure. Yes, Aisha Nadeem, that's what I'm saying. So send me in the group. Okay, send me in the group. Whatever you guys will send, I will do those. Otherwise, then we can continue with the same. Yeah, you're most welcome. Okay, okay. Assalamu alaikum wa rahmatullahi wa barakatuhu. Whoever will post in the group, those questions, inshallah, I will do. Ibrahim, jazakallahu khairan. Every day you give me this award of best teacher. It means a lot to me, by the way. It means a lot to me. Jazakallahu khairan. I will never forget your cooperation. Okay, okay. Assalamu alaikum wa rahmatullahi wa barakatuhu. You're most welcome. You're most welcome. Jazakallahu khairan for all your compliments and your encouragement. Okay, assalamu alaikum. Jazakallahu khairan, Ajwa.